In this video, we'll define what a polynomial is, and we'll also define what a coefficient is. Then we'll list examples of expressions that are polynomials, and also list examples of expressions that are not polynomials. To start, a polynomial is an expression that consists of terms summed together. Each term must be the product of a number and one or more variables raised to whole number powers. This whole number powers is going to be key, as we'll see when we look at examples. Since 0 is a whole number, a term can be just a number, and a polynomial may have just one term. The coefficient, or numerical coefficient of a term, is a numerical factor in that term. So as we look at what is a polynomial and what is not a polynomial, we'll pay attention to the coefficients, and then look at what are the exponents on the variables. That will be a critical piece as far as looking at what is a polynomial and what isn't a polynomial. So let's get started making a table that compares the two. So let's list out some examples of polynomials, and then we'll list some examples of things that are not polynomials, and all of these will be expressions. Okay, so now oftentimes polynomials are just going to have one variable, but they can have more than one variable, so we'll look at some of each. The first polynomial, something that's very familiar. Let's take something like 2x plus 3. So looking at the requirements there, the exponent on x there, it's just an implicit 1 when we just see 2x. So that's a whole number power. The coefficients, the coefficient on x is 2, and then we have this constant term that's just 3. A single term polynomial could be something like 4t to the third. And looking at another example, let's take 1/3 y squared minus 3/4 y plus 1/5. Now as we look at that, what we're looking for, we have y squared and y as the variables, and those both have whole number powers. 1/3 is a rational number, but it's just the coefficient. Same with 3/4, and then 1/5 is a constant term there. If we look at an example in two variables, let's take something like 3x squared y minus 5x y squared plus 4xy. We have x squared times y in that first term, and x is raised to a whole number power, and so is y. And the same happens in our second term and then in our third term. So there we have a polynomial in two variables. Let's look at one more. So let's take some slightly different coefficients. Let's take 1.2 q cubed and minus the square root of 5 times q plus pi. A kind of goofy expression, but the point here is to focus on those exponents. We have q cubed and we have q as the variable factors in those terms. The coefficient on q cubed is 1.2. The coefficient on q is the square root of 5. That's an irrational number, but again, it's our coefficient, and our coefficients can be any real numbers in polynomials. The last thing we have is this plus pi. That's a constant term. So again, this meets the criteria for being a polynomial. A more familiar one that we've probably seen involving pi is pi r squared. So we have pi times r squared. Our variable there is r. It's raised to the second power, which is a whole number power. So that is a polynomial. Now, let's go over and take things that are similar to these, but not polynomials. So if we had instead 2x to the negative 1 plus 3, that negative 1 exponent would not be a whole number power, and that would not be a polynomial. If we also, let's see, what else could we have? 4 times the square root of t. So there, t being inside that square root means that that expression is not a polynomial. Another one we could see if we had, let's take 1 over 3y squared minus 3 over 4y plus 1/5. So here, this 1 over 3y squared, if we recall our rules of exponents, 1 over 3y squared, that'd be the same as 1/3 times y to the negative 2 power. and that would not have a whole number power. So the fact that we're dividing by y squared there corresponds to a negative exponent on y. It's no longer a polynomial. Another one we could see, let's take q and raise it to the 1/2 power. And then let's add q to the 3/4. So there, the exponent on q is 1/2, and then the exponent on that other instance of q is 3/4. Neither are whole number powers, so that would not be a polynomial. One more example, let's take 3 times t, and let's raise it to the 1.2 power. So 1.2 is not a whole number. That expression would again not be a polynomial.